Did you know that humans see upside down? Well, not technically, because you might notice that you and I see upright. But this is only because our brains signal to flip the image upright. Pretty cool, huh? Today, we're going to be learning all about how we see and applying this new knowledge to build a DIY projector. Let's get started. Humans are able to see things because of the reflection of light. This is because light acts as a wave, and it's not the type of waves you see at the beach. Waves look like this. The number of waves in a specific time frame is known as frequency. You can kind of imagine it as how tight or how loose a wave is. For instance, a really tight wave has a high frequency because there are more number of waves in that specific time frame, versus a loose wave would have a low frequency because there are less number of waves in the specific time frame. Now you try. Do you think this wave has a high frequency or a low frequency? Exactly, it has a high frequency because there are more number of waves in the specific time frame. Different colors have different frequencies. For instance, the color red has a low frequency, versus the color purple has a very high frequency. The colors that we can see are known as visible light, and they consist of red, orange, yellow, green, blue, indigo, and violet. So how do we see color? Well, this deals with the reflection and absorption of light. For instance, to see green grapes, the color of wavelength green is reflected and all others are absorbed. To see a tomato, the color red is reflected and all others are absorbed. Finally, to see a banana, the color yellow is reflected and all others are absorbed. As you can see, the color that we see is the wavelength that is reflected. So now you give it a try. To see a blueberry, what color wavelength do you think is reflected? Now you're getting the hang of it, it's blue. So what about white and black? Well, white will reflect all wavelengths, versus black, which will absorb all wavelengths. For instance, a white piece of paper will reflect all wavelengths, versus my black water bottle, which will absorb all wavelengths. So understanding all of this, why on earth do we technically see upside down? Well, this is because of the shape of our eyes, which look like this. Our eyes have a biconvex lens. This means when light hits our eyes, what happens is that this light bends. When this light bends, this forces the image that we're seeing to be flipped upside down. But our brains are smart enough to revert this image to its original upright position. So now comes the fun part. Understanding all this new knowledge about how we see and our wavelengths, we're going to apply this to build our very own projector. Let's move on over to the craft table and get started. Let's get started. Here's what you're going to need.
A shoebox, a magnifying glass, black paint and a paintbrush, tape and scissors, cardboard, a pen, a ruler, and finally a phone.
Our first step is going to be painting the inside of our shoebox black. This is to absorb any surrounding light. Once you finish painting the inside of the box, give it some time to dry. In the meantime, feel free to decorate the outside of the box. Our next step is to take our magnifying glass and on one side of the box, trace it. Once done, cut it out. Make sure to ask a parent or guardian for help with this step. Once your hole is cut out, we're going to take our lens and put it inside of the box, attaching it with tape. With the magnifying glass now attached to the box, it will act similar to the human eye, in the fact that the projected image will now be flipped upside down. We'll fix this afterwards. Next, we're going to make a phone stand to hold our device. To do this, take your phone and place it on the edge of the cardboard. Once there, trace your phone 2 times. Once done, you should now have two rectangles. We're going to cut this out and score the middle in order to fold it in half.
Now you're going to grab a phone and put it to the highest brightness, volume, and turn rotation off.
To use your projector, place the projector facing a blank wall. Next, play your video and place the phone on the stand at the back of the box upside down. By placing the phone upside down, the image will then project upright. Adjust the distance of your phone to make the image more sharp. Now, turn off the lights. And here you have it, your very own projector. We learned a lot today, so here are some of the key takeaways. 1. Light acts as a wave and has different frequencies. 2. Humans see visible light. 3. To see color, the color that we see is reflected and all others are absorbed. For instance, to see a red apple, the color red would be reflected and everything else would be absorbed. On the contrary, to see white and black, white reflects all wavelengths and black absorbs all wavelengths, kind of like my paper and my water bottle. And finally, the reason that we see upside down technically is because of the shape of our eye that bends light. With your new knowledge of light and how the human eye sees, I challenge you to look around at the world around you and ask questions. For instance, how come when I sit in a black car under the sun, is it hotter than a white car? Or why in film and photography do we use reflectors to help with light? Now, while you're over here pondering these questions, I'll be eating some popcorn and using my new projector to watch a movie. Until next time, scientists.